Hi, everybody. It's Professor Mitchell. We're jumping back one last time into Chapter P. We're getting ready to do Section 5.5, which is about solving trigonometric equations. So I thought it would be helpful for solving trigonometric equations to have a little quick review of solving some of the simpler equations that will come up when we solve the trigonometric ones. So really the only two that we need to go over are linear equations and quadratic equations. Linear equations and quadratic equations. All right. In the original PowerPoint of this, there's a whole slide full of, there's 2 slides full of objectives. All right. We don't need any of those other ones right now, just these 2. Okay. All right, so first we have linear equations. So remember that a linear equation is an equation that can be written in this form. A and B will always be given real numbers. So we're talking things like, 2x minus 3 equals 0, stuff like that. And you know how to solve those. You can probably solve those in your sleep. So the only example I have is one that's actually a little more complicated than that, but I think it will eventually come down to something like this. And that is, right, well, first we'll quickly go over the steps. How do you solve linear equations? And again, the types of linear equations that we're going to be solving in Chapter 5 are usually not this complicated. But if there are grouping symbols, you get rid of the grouping symbols and you combine like terms. And then this is the part where I say you want to get your x's on one side and get your numbers on the other side. Okay. So for example, get all your x terms on the left side, get all your number terms on the right side. And that will generally leave you with something like, let's say negative 2x equals 8. And the way that you solve negative 2x equals 8 is you divide both sides by negative 2. And that gives you the your solution, x equals negative 4. Okay. We don't really have to go over all of these. Okay. And I think that I was actually just describing this slide, really. It kind of says the same thing. The last slide was talking about what are the things that you're allowed to do that won't mess up the equation. And this is talking about actually solving the equation. But it's exactly what I just said. Okay, so if you have something like this, it looks like I forgot to animate this slide, but that's okay. We have 4 times 2x plus 1 equals 29 plus 3 times 2x minus 5. So the first thing we're going to do is get rid of the grouping symbols. And the way that we do that is we distribute the 4 and we distribute the 3. So after I distribute the 4, I get 4 times 2x is 8x. 4 times 1 is 4. Over here, 3 times 2x is 6x. 3 times negative 5 is negative 15. So the next thing I'm going to do is combine like terms. I don't have any like terms over here, just 8x plus 4. Over here, though, I have 29 minus 15, so I'm going to put those together. That's going to give me plus 14. All right, let's see. Okay, so now we're going to put our x's on one side. We're going to put our numbers on the other side. So remember from the last slide, we were left with this. 8x plus 4 equals 6x plus 14. So the way that I usually write this is I'll put a minus 6x under here. I'll put a minus 6x under here. They're writing it a little differently. Okay. So that gets rid of the 6x on this side. And when I combine the 8x minus 6x, I get 2x. 2x plus 4 equals 14. So I have all my x's on the left side. Now I'm going to put my numbers on the right side. Okay. So 2x minus 4 or plus 4 minus 4 cancels. So that just leaves me with 2x. 14 minus 4 is 10. All right, and then finally, we're going to, we're at the point where you have x times a number equals a number. So you just divide out that number. You're left with x equals 5. Okay. So what is now strongly recommended is to take that solution, at least we think it's the solution, and put it back into the original equation just to make sure it checks. Okay, so I think that's what they're going to do on the next slide. All right, so on the left side, I put in 5. 4 times 2 times 5 plus 1. 2 times 5 plus 1 is 11. 4 times 11 is 44. And then over on this side, I plug in the 5. 2 times 5 is 10. 10 minus 5 is 5. 3 times 5 is 15. 29 plus 15 is 44. Woohoo! Okay, so the solution of this equation is 5. All right, that brings us to quadratic equations. So remember that a quadratic equation is an equation that can be written in this form. Okay, and again, a, b, and c will be given real numbers, so something like 2x squared plus 3x minus 1. Okay. All right, so the method that we really need, the only method I think that we really need to review right now for solving quadratic equations is by factoring. So luckily we have gone over factoring, right? We did that in section P5 when we were getting ready for chapter 5. Okay, so the way that you use factoring to solve an equation, a quadratic equation, is to use this fun fact, which says that if you're thinking, or if I'm thinking of two mystery numbers, and the product of those numbers is 0, the only way that can happen is if one of those mystery numbers is 0. Okay? It's one of my favorite things about the number 0. This does not work with any other number. You know, if I say I'm thinking of two mystery numbers that multiply to 10, I don't know, could be 1 and 10, could be 2 and 5. But if they multiply to 0, you know that one of those numbers has to be 0. So how do we use that? Well, let's go over these steps real quick, and then we'll use them in the example. First thing you want to do is write your equation in general form. So that's the form that we were just looking at. And then factor. Okay. So when you factor, you're going to be rewriting your equation in the form something times something equals 0. So you apply your zero product principle by setting each factor equal to 0. You solve those equations. Those equations will always be linear, like we were just going over. And then again, it's recommended that you check the solutions in the original equation. Okay. So here's the example, and again, I forgot to animate it. We want to solve this equation, 2x squared plus x equals 1. So the first thing I'm going to do is write that equation in general form. I really want this to be a 0 over here. So I'm going to go minus 1 on both sides. And that's going to give me 2x squared plus x minus 1 equals 0. Okay. The second step is to factor. Now, they did not show their work, right, with how they factored this. But it's pretty simple, this one, actually. I would definitely use trial and error for this one. I remember showing you trial and error in P5. The only way to get that 2x squared, that had to come from 2x and x, right? The only place that that 1 could have come from, forget about the minus, we'll worry about that later. The only place the 1 could have come from is 1 times 1, okay? So now I'm going to see, okay, how would I get the plus x? So I'm thinking about foiling these back together. I know that the F in FOIL is going to come out right. 2x times x is 2x squared. I know that the L is going to come out right. 1 times 1 is 1. But what I don't know about is the outer and the inner. Okay. Well, this is going to give me some kind of 2x, the outer. This is going to give me some kind of x, the inner. And I want those to add up to plus x. Well, I can make those add up to plus x as long as the 2x has a plus on it, which would have had to come from here, right? And then trying to find a good color here. Well, let's go with green. The x would have to have a minus on it, and that minus would have had to come from here. Okay. So that definitely factors into 2x minus 1, x plus 1. So our equation becomes 2x minus 1 times x plus 1 equals 0. So now we're going to set each of these factors equal to 0. The only way that 2x minus 1 times x plus 1 could be 0 is if either the 2x minus 1 or the x plus 1 is 0. If 2x minus 1 is 0, then that means that 2x is 1, and that means that x is 1/2, right? And if x plus 1 is 0, that means that x is -1. So it looks like our two solutions are 1/2 and -1. This is such a great example to get us ready for section 5.5. I could see an equation almost just like this coming up in section 5.5. All right, so we think our two solutions are 1/2 and -1, so now we can check those. Remember to check them in the original equation. So when you put in the 1/2, we're asking the question, is 2 times 1/2 squared plus 1/2 equal to 1? Well, 1/2 squared is 1/4, and 2 times 1/4 is 1/2. That's this 1/2 here. This 1/2 is this 1/2, so that just comes out to 1/2 plus 1/2 is 1. That works. And then when you plug in -1, the square of -1 is 1. 2 times 1 is 2. This minus 1 is this minus 1. 2 minus 1 is 1. So that one also checks. So the two solutions to this equation are 1/2 and -1.